Hello and welcome to How to Choose a Time Series Database and Get Started Fast. Today's webinar is sponsored by InfluxData and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. That Q&A panel is also the place to let us know about any technical issues you might be experiencing. A browser refresh will fix most audio, video, and slide advancement issues, but if that doesn't work, let us know in the Q&A and we'll provide further technical assistance. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources. There's a PDF that's helpful in explaining why time series matters, and there's a link to get started with InfluxDB. You'll also find a link to the Actual Tech Media Guerrilla Guide book club and a calendar of upcoming ATM webinars. So I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this webinar, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. Finally, one of the best benefits of an event like this is the opportunity to ask a question of our expert presenter. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card. This one for $50 for the best question. At the end of the event, we'll look at all the questions, pick out the very best one, and contact that prize winner. And with that, let's get to today's fantastic content. It's my pleasure to introduce you to our presenter today, Charles Mahler, who's a technical writer at InfluxData. Charles, welcome to the webinar.
Thank you. So let's jump right into it. So basically what we're going to be covering today, introduction to time series kind of in general, not only time series databases, but also go over time series data, some of the unique characteristics of it, some stuff you can do with it, kind of the ecosystem, and some general use cases that like companies are doing in the real world. So specifically, we'll be looking at time series for kind of metrics, real-time analytics, IoT, sensor data type stuff. And then, like I said, what is time series data? What are the differences between time series databases and more general purpose databases? And then specifically, we'll be looking at the InfluxDB data model. So what is time series data? Pretty simple, like the dictionary definition, it's just a sequence of points. Basically, it's at a interval of time, could be at a regular interval or irregular interval, which we'll go over in a little bit. And generally, like a stock market chart, you plot those points on a graph, and you either use it for historical reasons or you're trying to make a prediction based off that. You're trying to forecast what's going to happen in the future. But you're basically got your X and Y axis with time and a value at each of those. So starting off, a simple example would be the weather. You have temperature, and then you have time of day. So down below you just have at a regular time, and then each point you have your temperature is the value. You have stock exchange, which is really the classic example. Then we have cluster monitoring. So like this is more a DevOps or just basic kind of software type thing. We see this a lot. So you have like your CPU, your memory utilization, stuff like that. Maybe tracking it depending on your needs. Could be every minute, could be every second, could be for historical data at a longer frequency. And finally, you have healthcare. So this could be like your heart rate, stuff like that. Obviously, yeah, if you're in the hospital, you want to be tracking that. And if your heartbeat stops, it's not good. And you want somebody to take action quickly. So a little bit different. Those would be more regular, like every minute you might take a metric. These are another type where like a log. So that's like an event. You're logging things that, depending on like your website or your app, you could be At certain times, your traffic increases dramatically, so you're having an irregular metric in the sense that every time somebody does something, sends a request, maybe creates an account, depending on like what level of logging you're doing. These are being created and they have a timestamp on them, and you might want to track those. And again, in this case, be like distributed tracing. If you have a microservice type architecture, you want to be able to see what's happening as these requests are passed throughout your application and have timestamps, see potentially like where's your app slowing down, why, and then you can mitigate that. So as I kind of covered, the difference here is regular versus irregular. So like for these metrics on the left, it's like maybe every minute you're taking something. It's just it happens, and that's how you slice that data. And then on the right, you have these kind of events, or what we call irregular time series. So you can see, like, if looking at these dots on these charts, you can see this is like a classic regular. You're taking a snapshot of what that value is at the same time, no matter what. In this case, you can see with events, they can be bunched up at certain time periods. You can have a bunch of events all at once. At other times, they're going to be less frequent. Again, that just kind of reiterates a similar point. The big thing that you can do is that you can turn an event into a regular metric. So if you think about the stock market again, the price at any time, like if you look at the daily price, what that actually is the aggregate of, in some case for Apple, maybe millions of different shares are being traded back and forth across these exchanges. And that daily price, at the end of the day, they take a snapshot and say this is the price at that time. And anytime you look at like different time charts, what those really are is just a summarization of, in the case of the stock market, at that moment in time, here's what the price was. But what really behind the scene is each of those stock trades, whenever you buy or sell, that could be seen as like an event. It's an irregular event. Any given day, there's probably different numbers of buying and selling. Like if the stock market's crashing, there's a bunch of people selling. So that's those events behind the scene. All those millions of different events are kind of aggregated into a single number and converted into a regular time series as we define it. So now, what is a time series database? So we got the background on the data, and this is like one way to optimally store that data. So the characteristics are that obviously for it to store it, you need a timestamp. You need to know when the value occurred. Say a frame of reference. It's generated. It's going to be like we talked about, regular, irregular. Generally speaking, compared to normal types, that relatively speaking, it's going to be a much larger volumes of data. And because it's time-based, it's real time or near real time, and you want to be able to act on that data quickly. Because like if you're at the hospital and your heart stops, you don't want to wait an hour to be able to like crunch that data and notify somebody that something's gone wrong. Like you need to be able to act on this in real time. If it's a factory and you have $1 million machinery and something goes wrong, you want to be able to like either shut down the assembly line or shut down that machine before it completely gets even worse. So you're dealing with a lot of data, and you want to be able to act on it quickly. And that's the reason really you need a specialized database. And what comes with using this type of like specialized database is that there's no magic in the sense that there's just something that makes it perform so much better. It's the fact that when you decide, okay, this is the type of data we're going to work with, you can make assumptions and you can make trade-offs ahead of time, knowing, okay, we want to only work with this type of stuff. These are the common use cases. These are the common types of queries. And you can design that database to be much more performant for that select type of data and select type of use cases. So if you compare that to like a traditional relational database, it's kind of a jack of all trades. You obviously need it for a lot of different types of applications, but because it's trying to kind of be good at everything, it's not going to be able to optimize for certain things. That's similar to like a document database and NoSQL document type database. It's just not able to do the same stuff performance wise because it's got a different use case it's basically optimizing for. And so these are some kind of alternatives you could think about. So you have like Cassandra, that's like one of the really original, big NoSQL databases, and we've seen like early on a lot of people tried to make it work, and the result was often they'd have to build so much more stuff on top of it to try to make it scale for time series data that it just became a lot of complexity and it really wasn't worth it. Similar like MongoDB, Elastic, Redis. As for time series databases, you also have like Graphite, OpenTSDB. So those are kind of some for the broader ecosystem. Those are some names. And so why should you care as a developer? The big thing is that if you look at over the last like 2 to 3 years, DB Engines is kind of like a collector, like a for the database industry, I guess you could say. They put out a lot of data, they collect data, and what they've shown is that over the last 2 to 3 years, time series is the fastest growing category of database. So compared to relational, compared to like graph, some of these other more specialized databases, time series is growing the fastest, and that's just because as more developers learn about it, they start to see the value in this. They start to see all the potential new use cases that open up um, just because you get this new performance and you realize that stuff that wasn't really feasible before, hey, now we can use this data. Now we can try this stuff out that we would have never considered before. So there's a lot of rapid growth as a category. And then among those databases, InfluxDB, InfluxData is the current leader by quite a margin. So it's a growing category, and within that category, um, InfluxDB is kind of leading the charge. So some specific use cases. These are some of the primary ones we see. Um, and beyond these three categories, which I'll dive into, the way I think to think about it as the two even broader use cases with time series data is that you're doing optimization or you're doing automation. So optimization wise, um, as you get more data, you collect more data, you're able to make more accurate projections in the future. You're able to fine tune things. Like if you're having an assembly line or something, you can correlate different things that happen, and you can essentially like you can do predictive maintenance. You can do all sorts of stuff that makes you more optimized, less wasteful, and basically more efficient overall. The other one is automation. So you think like a self-driving car. It has sensors that are collecting data in real time, and it's going to then act in real time on that data. It sees something come across the street, it automatically stops. And beyond stuff like that, it's just all over. Like if we talk about DevOps, it's about instead of manually like having somebody on call to like try to scale stuff up, if you can do that automatically, like you have a sensor collecting different metrics. If you can see, okay, we're over a certain threshold of CPU, or predict ahead of time that, hey, we have a holiday. Like if you're an e-commerce store, we have a holiday coming up. Let's like preemptively just scale up the amount of servers we have ready. That's the type of two things I think, above all else, above specific industries, above specific kind of use cases. Those are the two goals: is you want to be able to automate more stuff, and you want to be able to make yourself more efficient. So now on to IoT. So primary use case, we see it in both consumer and industrial. So if you think consumer, it'd be stuff like maybe like a wearable watch, like a health device, where it's collecting your data, and we see you can use it whether just for like displaying, you store it, and people just want to see their stats over time. You can also crunch that data and like kind of create forecasts and projections and maybe early alerting systems. Um, we also have like smart home stuff. That's a very common use case. And industrial, it's the same thing where you have sensors collecting data, but it's just at a much larger scale, maybe in more kind of tougher environments where connectivity might be not guaranteed. But they're doing the similar things where they're just collecting data, making predictions on it, and just trying to be smarter with their data. DevOps kind of covered it. You're going to be collecting your metrics and data from your servers, your VMs, applications, could be events, and it could be either just kind of external monitoring, or you're monitoring that itself, but we also have a lot of developers that are making, at least for us, Influx to be kind of a core part of their product, where they're not just using it for monitoring activities, they're actually using it for adding features to their application, like real-time alerting, real-time features for their users. And that kind of ties into real-time analytics, whether it's business, social, being able to basically have access to better performance, faster queries. It makes that all viable. So these are kind of three core aspects of InfluxDB, why our users like it, is that beyond the database, it's more like a platform. There's a ton of benefits to building with or on InfluxDB. So first off is the API and toolset. So it's designed for developers. Everything's accessible through a REST API. We also have client libraries, which allow you to basically access it. I think we have 11 now, and we have a few community supported ones as well. So pretty much any major programming language, you can use those client libraries, build it right into your application. But you also have the option of using that REST API directly. So we have enterprise level customers that actually built their own platforms on top of it. So for a lot of those use cases, they want that direct API access because then they can access like authentication, so they can allow their users to create accounts and set up security on top of the stuff already provided for our InfluxDB. So having both of those, like the client libraries are really good for quick development. We have a lot of best practices built in, but we also provide that direct API. So if you want to maybe have your own kind of internal way to handle network calls and stuff like that, you can use that. Or you can also access some of those lower level granular features. And number two is obviously just the database itself, high performance, can scale pretty much whatever level. It's going to depend on hardware as always, what you allocate if you're using open source, and if you use cloud. It's really pretty much not infinite scalability, but most of that's handled for you. And then finally, we have community in the ecosystem. So part of being open source, there's not only a lot of learning resources, pretty much anything other people have struggled with, you'll find an answer for it. And then there's also the surrounding tools, which I'll cover later, is kind of some of our other plugins and templates and stuff that help you get started fast and are just another benefit of being open source. So this is just a few other reasons that you'd want to use InfluxDB. So a big part of that, you see open source Flux language. So it's one of our options for a query language. And it's, I guess more so, could be called a scripting language in the sense that in addition to just writing queries and pulling in data from InfluxDB, you can also transform your data with Flux. You can reach out to a relational database or any other external data source. You can make API calls, and then you can use Flux to join together. Like if you want to enrich your time series data, maybe you have some sensor data coming in, you want to grab like some additional information that's stored in a relational database about that sensor specifically. You can pull that in, join it together, and then continue running your analysis on it. A big part of that, again, is that it's designed for time series analysis. So that means you get out of the box, you get a lot of kind of functions that with like SQL, for example, as a query language, like trying to transform your data can be pretty complicated and get some really long kind of queries written out, like just in terms of complexity, trying to mentally look at them and untangle them. With Flux, it's a lot easier, and in many cases, we already have the function built in. So different kind of forecasts, it's literally like you just call a function and you get that forecast and you can project it out. We also have like moving averages, pretty much any common data transformation, the function's just built in there. So easy to share and extend, that applies to both the database and Flux itself as a language. Open source, so like I said earlier, we have companies that have built entire platforms on top of InfluxDB, and frankly, we encourage that because it's MIT, you can do whatever you want with it. You can contribute back to it, or you can just use it for your own product, and that's the good thing about open source. And then easy to get started, but powerful scale. So like I said, we have people who all the time tell us they started off with maybe some simple home automation project using InfluxDB. it was just so easy to use that eventually, and they enjoyed working with it so much that they take it to work with them, or they start a company. But that's how a lot of our customers, they start off just with a toy project, and they just fall in love with the product, and then they end up either bringing it to work or they'll start their own company around it, which we've had happen too. Oops. So this little diagram kind of shows the general, I guess you could say, life cycle, general way that you're going to be working with InfluxDB or any time series database as well. Like we have our tools for collecting data. So first you have Telegraph, which is another open source tool we provide. That has about 300 different plugins. So you can see there we have some of like some protocols, some services like AWS CloudWatch, Kubernetes. It says 250 plugins. It's now I think over 300. But pretty much any popular tool, any popular protocol, what Telegraph does is it allows you to, with a single configuration file, no lines of code, you can ingest that data. And then using some processor plugins, which we have a ton of community plugins, you can add fields to it. You can reach out to another service and bring in more data. You can filter out certain data points, and you can batch data points. Pretty much anything you could imagine. Telegraph makes that really easy. And then it pipes in directly not only to InfluxDB, but a ton of other like database vendors and providers have created their own plugins to tie into it. So I think there's 40 different output plugins as well. And like I mentioned earlier, those client libraries, basically any popular programming language we got covered. So if you want to, within your application, just use your write code directly, you can do that as well. Once it's in the database, so that's kind of like the accumulate your data. And then what you do inside InfluxDB is you're going to analyze your data. So we have built-in support for stuff like tasks, alerts. So you can set thresholds. You have different ways that you can define what you want to do. So an example for like our tasks is that maybe with data, especially time series data, when it's newer, it's got its most value. So you want to have very high granularity. Maybe you want to keep every second, you want to have that visibility into your data. But after a day or a week, it might not be as important to have that level of specificity on your data. So you set a task. After a week, you do what you call downsample, and you might take it from 1 second clarity to maybe a minute or maybe even an hour. And what that does is it saves you a lot of money on storage, and just over time, it's a big benefit. A lot of our users take advantage of that. So it saves you money. And compared to another database where you'd probably have to either have a external service to process that data and deal with it, with InfluxDB, it's literally like out of the box. You just have that support. We also, you can see here, again, once it's within, if you want, you can use Flux to do stuff like anomaly detection, machine learning. You can create user-defined functions to run kind of like custom transformations. You could send it to a secondary bucket. Like once it gets ingested into one, you can do something with it with Flux, transform it, move it to another area. And then, of course, you can also query. If you don't want to do that, you can always do like Python, it's probably our most popular programming languages because it's got a lot of data science support. So you could just pull that data out of InfluxDB, do some work with it in Python, and then just do it that way. And finally, we have integrations with different alerting frameworks. We can also pull to Telegraph, so you can use InfluxDB to actually input to Telegraph and then move it somewhere else. And then lots of UI frameworks like Grafana, different dashboarding tools, stuff like that. So that's kind of common, generalized way that we see users taking advantage of InfluxDB. So to just reiterate the kind of benefits of InfluxDB, so easy to get started. In addition to Flux, we also have InfluxQL, which is like you'd expect, SQL-like query language. And in the future, we have plans to add just general SQL support. So if you don't want to kind of mess around with learning another query language, those options are available. A big thing again is no external dependencies. You can just install InfluxDB OSS um, from a binary. It's got a low kind of resource footprint, and you can just get started with it right away. We have, again, horizontally scalable. You can start off with OSS. You can use cloud. There's some open source tools to kind of do some clustering support. And we also have, if you're on premise, we have Enterprise Edition, which provides that clustering support, and you can run it and manage it yourself. And we have that cohesive time series platform, so that's Telegraph. We have some tools to help with stream processing. And for IoT workloads, we also recently added what we call edge data replication. So I'll mention later we'll have some use cases where we talk about this, but we saw so many users that did stuff where they have kind of like edge workloads. If you're like kind of out in the field that have resources out there, and they'd have to, a lot of customers are reinventing the wheel where they had to, how do we get our data from our devices on the edge back to the cloud for like long-term analysis. So that's another recent feature we added, which is called edge data replication, which makes that simple. It's basically one command line command. You just point it to another InfluxDB endpoint, and you're automatically just replicating that data. So now we're going to take a look specifically at the InfluxDB data model. So here we just have kind of a standard chart. So obviously stock price, and we're going to look at how you would map this to the data in InfluxDB, like how this would look in the database. So first thing at the top, this would be called a measurement. So it'd be stock price, and your measurements are going to be stored inside what in InfluxDB is referred to as a bucket. So one running instance of InfluxDB can have multiple buckets, and within those buckets, you can have your measurements. So we have our metadata, so that's tags, and so you can see like those would be the stock names. So you have like Apple and AA, AA. So that's tags, obviously it says our index, so that's something that I can cover in a little bit, or maybe if anybody has questions about that, you can throw that in the QA. But tags are allowed, like you generally want to set those as anything you're going to be querying by. You don't want to set every value in your data as a tag, just because that can cause some scalability issues because it'll basically index all those. So that is one thing to keep in mind. So collection of all tags is what is called a tag set. Your y-axis values are fields. So in this case, your price is going to be your field value. Unlike a lot of kind of competitor time series databases, we generally have support for a lot more different data types. And again, all these fields, you can have multiple, not just price, like you could have additional values. If there were, there's called a field set. An X value is like by default, that is a timestamp. And with InfluxDB, you can either, like when you pass that data in, you can define it yourself. If you don't, it will automatically be put on there by the database itself. It's required. So that can be a problem if, like, could be related to, like, if you have old data and you don't have that field defined, it could cause problems when it ingests. InfluxDB just puts on the current time as the value. So for historical data, you obviously want to make sure you attach that timestamp. So now, how do we represent these like as an actual kind of text format? So with InfluxDB, it's called line protocol. And so if we map these out, you can see here's the measurement name, that stock price underscore. That is the measurement, which is shown on the label of the graph. You then have your tickers, which are basically that's your tag in this case. You have the stock price names or tags, and you have the market as another tag. So you have NASDAQ, New York Stock Exchange. Big thing here to keep in mind or to pay attention to is one, these commas, and two, the space, like between the market and the price. That space is important for InfluxDB to kind of parse that as it's ingested. That's what defines that first space, is what separates the tags from the values. So if we had like a second value that can set a price, maybe we have, I don't know, some other value, like maybe like the daily, like whatever transaction that was for like buying or selling, maybe attach that as value. That would be another comma. So for your, just like with those tags where they're broken up by that comma, you do the same thing with your field values where they're differentiated by putting a comma between them. And then finally, the second space is again very important because that's what signifies that the timestamp is up next. So this is again called line protocol, and that's how, if you want to write data directly into InfluxDB, that's the format. A lot of our tools, like if you use the client libraries, that abstracts it away, and you can just treat it like a normal JavaScript or Python object, and behind the scenes, it will automatically kind of format your values so that it matches this line protocol. This is, yeah, just the same thing. Measurement, like you see the commas, tag set, field set, timestamp. And yeah, so again, I already kind of covered this, but yeah, oh yeah, you have your tag key. You want to make sure you do that as well. Equal signs, no spaces between the equal sign and your values. And this is another important concept. So series is basically, you see the highlighted, so that would be a single series. So measurement plus tag set, that would be your series. For each individual timestamp, that would be like one of these points inside that series. And the thing to keep, this is where the tag values come into play, is that if you add, as it currently stands with the way our backend storage works, if you were to define like a very, like a value for a tag with a lot of different, like if you use like a unique user ID, like a UUID, that could potentially cause problems because since every one of those tags are unique, that means you're creating a series for every single variation of that tag. So generally speaking, unless it's absolutely necessary, you want to do something like in this example where the tag set, there's only 3 potential options for those values. So you have A, AA, and then Apple. So you usually want to do something that's like within a fixed range, unless it's absolutely like essential for your use case. And then you kind of have to do some other stuff to potentially those values because you don't want like an explosion, basically is what we call it, of like these series because that can begin to kind of slow down the database. But by default, we are like it's schemaless database, which is nice for getting started fast. But that is something that is always a downside of not enforcing a schema, is that you can kind of get yourself into trouble if you're not careful. These are just some more kind of general examples. So you have line protocols, you have CPU, you have a tag of host and like the server ID, then you have your value, you have temperature, zip code, country, and then your values. So this is an example where you have multiple values. So you have like the temperature, you also have the humidity as another, and then you have, in this case, a response time measurement. You're tracking the type of method. So this would allow you to filter, like maybe you want to look at post requests, maybe you want to look at only GET requests. You could filter based on that and then see like what the value is. This also shows that you can define the precision. That's another benefit that some of our, like we have a space like rocketry company who uses us, and a lot of databases don't provide nanosecond precision. So if you have very high frequency data, some of those databases just don't support it. So a lot of, or at least a chunk of our customers say that that's one of the reasons they went with us, is that we provide up to nanosecond level precision. But in some cases, you don't need that. So here you can see they just want millisecond precision. And that'll save you potentially some money in terms of not needing all those extra data points just in terms of precision. So now on to some real world use cases. Here we have Beebox. So what they do is they are a solar company that's focused on Africa specifically as a market. And what they do is they, obviously they're good for the environment, but they also at the same time are helping their users save money because for their standard customer, they currently used or like previously used like a lot of diesel or kerosene based generators. So that's not efficient, it's expensive, and it's also bad for the environment. So some data about Beebox. They have 2.5 million people currently powered by their solar panels. They've replaced 2 million different generators or lamps that were burning kerosene and diesel. They collect using InfluxDB billions of metrics per day. And since they started using InfluxDB, they've scaled their number of customers by 10x, but they haven't run into any issues related to scalability. So the big thing for them initially was, and I think this shows the power really of the database, because you find once you have it, you don't even like realize initially all the stuff you're going to use it for. So first off, they just use it for basic monitoring, which is like what a lot of customers do. So there's monitoring metrics, stuff like that. But eventually, they're able to use that same data for actual uncovering new streams of revenue and doing predictive maintenance. So, like for example, they saw that they were surprised at the times that people were using their power. People were running out of power during the night, and they didn't understand that. And then they looked at the data. They asked their customers why they were using so much electricity at night, because you'd expect, oh, they're asleep at night. Why would they be using a ton of electricity? And they found that because some of these rural places in Africa, just for safety reasons, a lot of people tend to leave their lights on at night to like scare away anybody who's potentially going to try to like break into the house, stuff like that. So they're burning through a lot more electricity than originally predicted. So what this allowed Beebox to do, once they saw that in the data, was they could preemptively sell them like a larger battery and like a larger number of solar panels, because they could predict ahead of time, okay, they're going to be using their solar panel, they're going to be using electricity at night to keep some lights on. We're going to preemptively be able to sell them a larger battery. And they're also able to now they brought in InfluxDB, these metrics, as part of their customer service solution. So they had a lot of, before they would be reactive, where somebody would call, say, our battery's dead, we need you to come replace this. Now, using that data, they're able to reactively, before the batteries even fail, before a solar panel even fails, they're able to see that the performance is degrading, and then they're able to send people out to fix it, which keeps their customers happy. And not only that, they can kind of batch together jobs. Instead of sending somebody out to just do one house, they can see, hey, there's 5 places in this general area that also need some maintenance done anyway, so why don't we just do them all at once? So basically, I think the summary there is one that goes into like kind of the optimization and efficiency points that I talked about earlier, where start off just with monitoring, but now they're actually making more money than they previously would have, and they're being more efficient in terms of maintenance costs because they're smarter with how they make their decisions. Let me see, 500 million real-time data points. So again, that kind of covers the scale. And I think the big thing is that they've 10x their customers, but they haven't really had to do anything. They haven't had any like major growing pains because they built on InfluxDB and it just scaled for them. So this is kind of their general architecture. So their solar panels send off their data to AWS. Inside AWS, they take that raw data, they store it in InfluxDB, they do a little bit of processing with Python, and then they send it back to InfluxDB. And then they have Celery, which is like a task queue, and they use that to handle any potential alerts. And they send that to like whether it's predictive maintenance or anything related to that. That's how they handle that. So they use our Python client library, and that's kind of just their basic architecture. Again, this is kind of how this is just their, like a real world. We went over those line protocol and schemas earlier. This is like a real world, like what they track. They have voltage, current, temperatures, their fields, and for them, they have their tags. So for product ID, battery type, and this could drive kind of investment decisions as a company in the future. So they have battery type, like maybe they see that certain battery types just perform better. So, hey, instead of splitting 50-50 or however we currently buy these batteries, let's just focus on this one type because it just performs better. And they also have product ID, like maybe certain brands, certain type of battery performs better. They can do the analytics on that and make informed decisions based upon that. So this is a more standard, like that was kind of an IoT IoT workload, this would be what a lot of software engineers are doing. It's like monitoring type use case, DevOps. In this case, we have Wayfair. So what they needed was e-commerce is very kind of spiky workloads. So around holidays, like if you think Cyber Monday, Black Friday, you can get up to like 5 to 10 times more traffic than your normal kind of baseline traffic level. So they not only wanted to be able to monitor like all the time, but they wanted to be able to preemptively test their infrastructure and make sure everything would hold up. So what they would do is it's called real user monitoring. They would create simulated workloads and then they'd use InfluxDB to kind of test that in addition to their normal monitoring, stuff like that. So before they had been using kind of a legacy um, time series database, and they're having all sorts of issues related not only just handling scale um, at the moment in time, but it's also just much more expensive because one, they need to allocate more hardware, and the other thing, which you might not think about, is that the way the database compressed data was expensive. It wasn't as efficient, so they had to spend more on storage costs just because um, the way that database compressed stuff was not great. So basically, end result is not their site's more stable. Um, they are able to test more efficiently, do a lot more experiments. They store 50 million different real like user monitoring metrics per day, uh, and that includes 495 distinct values. So for like users using the app or using their browser, they track 495 different things. Could be like device type, network performance, what actions, like where they're clicking, stuff like that. So they can do A/B tests, see if we shift this, do more people click, and they can track that with InfluxDB. And Wayfair is kind of an example. I mentioned they kind of had to reinvent the wheel with how they replicate data across data centers, and now this is something that because of customers like this and similar that we've seen, we now have that edge data replication feature where you can move data around from whether it be out in the field on a device to your cloud or in between regional data centers. You can use that feature to do that. You see, yeah, this is so they were using Graphite, which is kind of one of the original time series database type things. That's what it was used for, metrics and storing stuff like that. The bigger limitations being the no clustering, storage infrastructure was difficult, no real scaling or pipeline solution, and just general performance. InfluxDB, you can see just kind of the pros and cons there. All right, so that's pretty much it for the presentation. We got Q&A. You can see right here, just if you're interested. I know there's those handout links, but you can also see these links here. We have our Slack, which if you have any questions, if you get started, you want to talk to our developer advocates, stuff like that, or just other members of the community. We have our forum, which, like, again, if you're running into any issues, we have tons of old questions answered there. So pretty much anything you run into, somebody's probably asked the same question, you can find an answer there.
Okay, great. Well, thanks, Charles. Really interesting stuff. Great presentation. Let's get into some audience questions. And while we do that, we're going to put a few poll questions up. I will come back to this community slide here in a bit. So, in case anybody wanted to grab those links and didn't get a chance to. But the first question here is, how important is time series data to your application development? And we'll just leave that there while we get into some of those audience questions. So, Charles, this first one came in early about why not just use a relational database? And you talked a bit about that, but I wonder if you could elaborate on it.
Yes, I'd say, again, it always depends on your workload. Um, and if you don't have a huge volume of data, it is okay to use a relational database and not add like managing another service, adding another database is some complexity. So I think it always first thing you should do is don't just add something to add it. You should look at like how much you expect to scale over time, and if it makes sense, you should probably just build on top of the time series database to start. Like if you look at the numbers and say, hey, we plan to scale to this level. It makes sense to just do it now, not worry about having to migrate in the future. So I think it's always about trade offs and just doing what makes the most sense. I'll also say beyond performance, there's a productivity aspect, which I kind of touched on with Flux and some of our tools, is that you also kind of should keep in mind like what is for implementing this. Like if I want to do downsampling, if I want to do like a roll up type thing, where with Influx you kind of get that out of the box. Um, on the other hand, with the relational database or maybe like a more general NoSQL database, you're going to have to spend developer time building out that functionality. So that's another thing beyond just pure performance. Think about like your developer time as well.
Okay. All right. Yeah, great points. Hey, something else related to that. You mentioned about the languages. As somebody's, was sort of weighing that option of, do I need to scale to go beyond, relational database? How much of a learning curve is there from, you know, SQL expertise to say like the InfluxQL, and then of course you mentioned that you guys are looking at, supporting SQL directly, but what's the learning curve like from SQL to InfluxQL?
I'd say it's pretty much like all the stuff you expect is there. It's mainly, I'd say it's more like an extension. Like there's a few kind of time series specific methods and stuff for like aggregating data. So a lot of it's like you can carry over a ton of your knowledge. Flux,
Hmm.
which is more like a full-fledged query, that one has a little bit more of a learning curve just from like kind of visualizing how the data is being transformed in your head. But it's very similar to
Right.
like a combination, I'd say, of like JavaScript and kind of like almost like a command line pipe, like where you pipe your data, and at each step you can kind of transform it and see what's going on with it.
Very cool. All right. And before we get to the next question, I just want to move on to the next poll about how you're storing your time series data currently. So leave that one up there for a bit. Um, the next few questions we have here are about scalability. The first one comes from Amir, who's asking, are there any limitations on how much data can be stored?
Yeah, kind of depends. Like, I mean, it always comes down to like, especially with the open source version, it comes down to hardware. Like, if you put it on a Raspberry Pi, you're gonna have a lot different performance than if you put it on a huge server with like a ton of RAM and a ton of storage. So that's with open source, that's always the kind of the obvious thing. With
Yeah,
cloud, pretty much it's auto scaling, so it's really not a major issue there. There's also some stuff that like I kind of mentioned with the tagging, depending on like some people kind of go crazy with the tags. They tag stuff they don't need. So for certain volumes of data, um, you might have to start thinking about, hey, maybe I don't need to tag this. That can impact performance for your queries if you tag everything. So that's it's kind of a balance. But for most workloads, I mean, we have people ingesting like I think stand like millions, tens of millions of data points per minute per second. Like there's some pretty crazy numbers that you see. So for most workloads, you don't even need to think about like optimization or anything like that. And like I mentioned earlier, it's still kind of work in progress, but it's getting there. Is like that new like where we're going to add SQL support. Part of that is like our new kind of back end engine, and what that should solve is like in theory, from what we've seen, like basically all those issues with tags, basically. So in the future, even worrying about that really won't be an issue.
gotcha. Okay. Um, and that leads to another question because Amir had part of his question about what are the minimum hardware requirements for running the database instance. Um, so I guess I'll just leave it at that first. Are there minimum hardware requirements?
Yeah, I'm trying to think. I know in our docs, if you just want to Google it, I forget what the exact, but we have recommendations for like this much RAM, this much. I'm trying to think, and they kind of like it's broken down by like how many like your estimate like queries per second, how many do you expect, and it kind of gives you some
Right.
recommendations for what you should give it in terms of resources. So off the top of my head, I don't remember like exact like, hey, if you want to write this much data, you need this many gigabytes of RAM. But you can look. We have those resources available, and I'm sure if you look at like our forums, there's people who've asked those questions, and you can like get some community-based stuff that's not like I don't know. Like if you don't trust our docs, you can look to the community, so you don't have to worry about bias or anything. You can see what they're doing for their open source installations.
Yeah, yeah. Hey, speaking of the community, what's your sense of, do most people, most customers, store the data on their own hardware, run it through, their own data centers, or is it, primarily people are using the cloud? Do you have a sense of that?
Uh, I think historically it's mostly been in their data centers. We had a lot of enterprise users and just people starting off using open source. Over time, like the cloud product has matured quite a bit, so it's starting to be like 50-50, I'd say. But we still have a lot of people
Okay.
who just start off open source and they either stick with it or eventually they say, hey, uh, like we talked about those edge data use cases, they'll stick with open source for their edge stuff, but they want historical access for maybe like rather than a developer using it for monitoring, they also want to pipe that data for
Hmm.
like business analysts, like Beebox type use case where maybe they want to kind of look at that data for like maybe business trends rather than like is our application running. Maybe they want to look at like how people are using the application. So it's like a different subset over time. So a lot of our edge, that's what it is. Like at the edge, they're doing like monitoring type workloads. In the cloud, they might be doing like kind of business type queries.
Gotcha. And I am going to move us forward to our last poll, just about whether you're interested in learning more about InfluxDB. But on that topic of cloud, what clouds do you run on?
It's basically the three major clouds. So Google Cloud, AWS, Azure. You can roll up the InfluxDB cloud. You can run it from within those. And then obviously our open source you can run anywhere. Enterprise you can install anywhere. But I think we have it with I know AWS and I think Google Cloud is that you can actually we did I think I forget what it's called the exact name of it, but through their marketplace I think you can use any like your cloud credits, anything you've got like your pre-allocated budget for the cloud, you can now
Hmm.
use that budget towards InfluxDB. So that makes I know like a lot of our customers they've said that makes it a little bit easier to get started just because they don't have to like create a whole separate sales process, go through that whole thing. They can just use their pre-allocated budget just to test out InfluxDB on those cloud providers.
Okay. All right, great. Um, Billy had a question. Says, I'm not sure if I missed this, but are there any device limitations for accessing the data? Um, I guess as far as you know, mobile, or OS, etc.
Uh, yeah, so device limitations. I guess I don't know. Depends on the context. I mean, I guess anything you have network access to. If you're talking about like accessing InfluxDB from something, as long as you
Hmm.
have authentication, like network access to make the HTTP request, you can access it. And you could also do you could do some like on-device stuff as well. Like we've seen that where maybe you replicate your data to the OSS instance so it's closer, and you keep like another instance kind of siloed away from that. So um, yeah, I guess I'd need a little more context if I don't know if I understood the problem correctly or the question correctly in terms of how to
Okay.
access.
Yeah. Um, we had a question from Matthew, about access. What identity providers do you support for authentication and permissions, and how is role based access controls? How are those managed?
Yeah, off the top of my head, I know we've been rolling out some more fine-grained controls. I know we've had a lot of customers request that. I think like we just rolled out, so it's like I don't know what protocols exactly, but like I know now we have
Hmm.
like organizations, so you can separate user accounts, so you can be a member of multiple organizations. You can break it. So we have a lot more fine-grained access now, but I think that's um, as we go like a work in progress. I think for a lot of like where security is really important, we have enterprise, and that gives you a lot more control. So I'd check out. I'm not off the top of my head. I'm not entirely sure like what kind of stuff we have for cloud, but I know for enterprise that'd probably be the go-to. Where security is like extremely important, that'd probably be the go-to.
Right. Okay. Super. Um, well, so Charles, we're running up on time here. This has been great. I do want to just say, if somebody wants to get started with InfluxDB or InfluxData, um, what do you recommend?
I'd say just go to our website. We have the option get started like the fastest way. Obviously, cloud. There's a free tier, so you can basically put in your email and you have a cloud account going, and you can start off with a sample data set. We have like some new kind of tutorials that get you started with like the client libraries. And you also have the option, like if you prefer OSS, we have Docker images where it's like just use Docker and you get started right away. So either of those, you can get started for free and just start playing around with it. Check out the documentation. So yeah, I'd say both those are valid options.
All right, tremendous. Well, thanks, Charles. Appreciate the presentation. It was really really informative, and thanks for all the insights in the Q&A as well.
Yeah, thank you.
All right, and before we wrap up, we do have one other piece of business. It's the $300 Amazon gift card prize drawing, and the winner of that gift card today is Petra Leonard from New Jersey. So congratulations to Petra. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank InfluxData for making this event possible. And thanks as always for attending and for your great questions. That concludes today's event. Have a great rest of your day.